Yes, so this talk is it's the first time we've given this talk. It was sort of at request because we were tending to skip over some things that we tend to take for granted, and a lot of you may not. So by definition, really, I may skip over something that you think is important. So please raise that in the chat, or and then we'll interrupt, and we can move along on that basis. Yeah, and this is just a collection of various things that will prove useful to you, hopefully, when observing. Some of them you're probably already familiar with. Yeah, if there aren't any questions asked, this is probably going to be quite a short talk, so please do ask questions if you have any. Something just that, oh, and the other thing is that a lot of this will have been covered by Amber, Bren, and Dave in this morning's talks. But it's better to repeat things, I think, than have people confused about what's happening. One thing I noticed that was absent from the talks earlier is just people aren't always clear on what the roles of the GBO stuff they're interacting with are. So I just wanted to make that a little clearer. The GBT operator is not a scientist. They are at the telescope. They are your point of contact when you're observing. But their priority is the telescope, and they don't know what you're doing, and they may or may not care. They care about the telescope and what's happening with that, and if anything is going to break. They will not be looking over your shoulder when you're observing, so don't rely on the GBT operator to tell you if anything's going wrong in terms of your data. The person who has more responsibility from that side of things is your project friend, and there's someone assigned to your project who usually has similar scientific interests to that project, although we can't always cover all areas of expertise here, so it's not guaranteed that your project friend is an expert in your field, but they should be an expert on observing with the GBT, and so they can help you with your script writing, give you some advice on calibration and observing method, and so on. And then after your observations, can advise you on data reduction. The point I'm trying to get to by saying that they may not be an expert in your field is that they are not responsible for your scientific decisions. They can give you some advice. They can tell you how you might improve your sensitivity with different switching methods or something like that. But ultimately, your scientific decisions are yours and have to be made by you. We often get a little bit of confusion about the difference between your project friend and the on-call support scientists. So here, the same group of people, the scientists and data analysts, are project friends, and we do shifts on call that we rotate through. And so if you happen to be on call when a project is on the telescope, you're the person who will get that call. And that could be anyone. So it's not necessarily going to be anyone in your field. And if someone needs some help setting up for the first time they observe, which is, if you've never observed with the GBT before, we tend to have people sit in on those observations for your first session or two. And that may be your project friend, but it also may be the on-call support scientist. And so they'll be the person you'll probably be talking to on your first observing session, or if something goes wrong during a later observing session. But in terms of getting help with your scripts, calibration, data reduction, it's your project friend you should go back to. Yeah, just wanted to add that in. Now, in terms of logging in, I wrote this when I thought that you already had accounts. It's not clear to me if the FastX account is the same thing as your regular computing account, but hopefully we'll be getting that figured out today. Your regular computing account will be active for 2 years from the date you last logged in and interacted with any files. And that's usually ample time. If you go more than 2 years without logging in and you need your account reactivated, then please contact either your project friend or the computing help desk. The easy way to log in is going to be covered a bit more later on with Andrew's talk. And I was just going to give a little demonstration of this. You just go to that link in my talk. And you'll have a selection of machines and environments you can log into. Now, generally speaking, if you're observing, you log into Arial or Titania here, and then it's should be fairly clear what the data reduction machines are as well. If you're just logging in to have a look at some files, maybe even do a little bit of script editing, then this XFCE is probably your best option. And that will take you into a Linux environment. Some people I know aren't necessarily all that familiar with Linux, so I'm going to go over some of that a little bit. Some of you may be more familiar with it than I am, so you can tune out for a second. Yes, so as I said here, if you're going to use Astrid, Clio, GBT IDL, pretty much anything, you probably don't want this XFCE. If you're, as I said, I said you might be editing some scripts. That depends whether you're going to be using Astrid to do that or not. And the first thing you really want to do, I'm going to skip over that, is bring up a terminal window. So Linux can be a very complicated thing. It can be quite scary to people if they're not familiar with that kind of computing environment, but it's pretty easy to get started. So we start up the terminal window just simply by clicking on this little terminal here, and that'll be in my home directory. And then if you just, you can type like ls for list, and that'll tell you all the files and directories in your current environment, in your current pathway. And just a little about paths. So here we are. You have your home directory, which is where I'm logged into now. If you type pwd, that will tell you the path of your working directory. And that's /users/lmorgan, and it'll be obviously your username. And you have 20 gigabytes to play with in this area. And it's not really meant for the hard data crunching, putting large files, putting large data files, anything like that. It's for script editing, maybe even producing some images and so on. But if you want to do any real data handling, then the place to do that is in /home scratch, and then your username. And there we are. And this has a much larger quota. Don't know if it has a quota at all, actually, but it is monitored for how much space you'll be using. And it's meant for data sets that are actively being worked on. So if you have, terabytes of data in there and then don't touch it for 2 months, you will get an email from the computing department telling you to either download it off site or actually finish up whatever you're doing with it. This area is not backed up. Your home area is. So anything that's truly important, keep in your home directory. Obviously, your data are important, but they are also archived. So the worst thing that's going to happen is you may have to re-reduce all of your data. But you only have to do that once or twice to hopefully learn your lesson and never need to do that again. Let me see. Okay. So back to some Linux commands. Really, this is something you're just going to have, if you're not already familiar with a lot of these, you're going to have to sit down and learn them in your own time, because I'm sure you're not going to just take it all in from this one slide. But here are a bunch of Linux commands that are pretty helpful. Here's how you move around on the Linux system, how you create directories, remove files, directories, CP and MV, copying and moving files and directories. And there's always this help flag, which annoying, because Linux is created and maintained by many, many different people, standards can be hard to come by. So sometimes you'll have a -- help. Sometimes that'll be just a minus help. Sometimes it'll be -H on all different things. but there's usually some sort of documentation you can bring up. I don't know if LS has that. Yeah, there you go. So there's the help page for LS, and I'll just give you some examples, and it'll give you all these flags that you can use. So these tend to be very useful. I use this one a lot. ls-lat tells me all my files, even the hidden ones. R is for recursive. It gives you times and dates, and these are the permissions of those files, who can read, write, and execute them, any of them, and so on. So anyway, even more detail is available if you type man for manual, ls, or whatever command you want, and then it'll have a much larger set of help directions in there. Another very useful command is apropos. So I always forget the name of the PDF reader on Linux. And so every once in a while I'll need to type apropos PDF. And of course there's 150 different applications that refer to PDFs, but this will tell you all of those. And the thing I'm looking for is this events, showing a printing preview of PostScript and PDF documents. So yeah, apropos can be very useful because no one can remember all of the Linux commands for everything. And there are many, many more. And once you get into writing shell scripts and so on Linux, then these become very useful. But like I said, I'll leave you to look those up on your own time. One thing you need to avoid on Linux is using spaces in directory names and file names, because they will typically interpret that as being two different files. If you write my directory with a space, it will either think you're trying to refer to two different things, or if you are successful in creating a file name with a space in it, you'll then have to use a backslash to refer to that. And that doesn't always work depending on the application you're using. One thing that not everyone who is a Linux user even is aware of is if you hit the up arrow, it'll cycle back through the commands you've used in that session. And that can be very helpful. Stop you having to, save you having to type everything out over and over again. Another one that's my particular favorite. So I exited that. If you got to that and you think, oh, actually, I don't want to do that, you can hit Control-C and you'll cancel that order. Hitting Control-R allows you to search back through the commands you were writing. So if I start typing, any string that was in one of my commands, PDF, for example, it shows me all the commands I've used that had PDF in it. And if I keep hitting Control-R, it'll cycle back through all of those commands that have PDF in it. Another thing that I completely take for granted these days until I end up on a Windows machine, but I can select some text and hit my middle click button on my mouse, and it will paste that text into, whichever window I click on. So yeah, makes copy and pasting a lot simpler. And if you're more used to Windows, this will trip you out for a while because Control-C, as I said, cancels a command. So if you're trying to Control-C to copy a piece of text, you're going to be unsuccessful. Also, I want to, if I want to list a file here. So I have several files called spec something. If I double hit my tab button, it'll tell me all of the files available that begin with that prefix. And when we exit, we type exit. And that's sort of just easy way of getting you running with Linux. I'm sure some of you already know all this. Clio and Astrid have already been covered by Brennan and Amber, and GBT IDL is going to be covered next. So I wasn't going to go into too much depth with those, but I did want to just mention a few of the quirks and maybe some of the tips that can help you get by a little easier on the Greenback system. Any of those packages can be opened simply by typing their name in lowercase on the terminal line. Clio has some fairly sparse documentation, but does have good help files. So you can always learn a lot by just looking at these and maybe picking up a tip or two as well. There are many, many Easter eggs in Clio that can be quite hard to find. Yeah, if you look through all the help files, you'll probably find one or two. One tip I like is if I type Clio status, I don't have to bring up the Clio GUI and then select status. It will just immediately start that window. And as Amber pointed out, that can take a while to get that started. She also mentioned the Clio container, which I was going to bring up as well, simply because I like the tabbed format. Should bring up a couple of things. Yeah, now I have tabs in Clio, and I don't have to cycle through all my displays to figure things out. One thing I do like in Clio is if you hover over these boxes, let's try one of these. There we go. It gives you a short description of what that box is actually telling you. So if you're completely mystified by what you're looking at, that can be very helpful. Okay. Also, another thing that's very useful is if you double right click on a value, like this converter rack power value, it will bring up a real-time chart of that value. And you can sit and watch what's happening. For example, if we were to do a pointing scan right now, and I clicked on pretty much anywhere in the IF chain, you would see the power go up and down as you scanned across your source. And this can be very useful for diagnosing problems or checking on things. Okay. Now, something I sort of skipped over with the Linux information is that you can sometimes, if you keep a task in the foreground, so if I start Astrid, that will actually take over my terminal window. And a way to avoid that is you can hit Control-Z, and that puts the task in the background. Well, actually, it suspends the task. Then by typing BG for background, I can put the task in the background. It will continue to run, but I will have access to my terminal without having to open a new one. You could also achieve the same thing by typing Astrid space ampersand. And I'm not going to get too much into Astrid because there's a lot to it. One thing I was just going to bring up as a tip, which is just something I do and several others do, and in contradiction of what is in the Observer's Guide, is that when you put your configuration into your observing scripts, in the Observer's Guide, it tells you to put those in an external file and then refer to them from your Astrid Python script. I actually recommend that people don't do that, but instead put their configuration in their script itself. And this is because we can retrieve the Astrid logs later on and see exactly what your configuration was. If you run a set of observations, then you alter the script on file, we can't tell that that's happened, and we can't tell what the configuration was when you were observing. So if there are any problems, just a lot easier to diagnose if you kept your configuration in your Python script itself, because we don't log anything that's referred to through an exec file. I'm sure there are arguments for doing it the other way too. It's just my personal preference. One thing people don't always realize immediately is that Astrid is essentially a Python notebook. And so, using Python dictionaries, loops, print statements, and so on is all possible within Astrid and fairly straightforward, and can be very useful. It's not a self-contained system. GBT IDL is another application that just has a slew of features and details that just aren't going to be able to be covered here. But just in terms of knowing what you're doing with GBT IDL, when you're observing, the telescope is and the system is producing many FITS files and different types of file. And we'll have a FITS file for the antenna. We have FITS files for all the different banks on the spectrometer that you're using, and on and on and on. FITS files for the IF configuration and so on. We use SD FITS, which is a filler, to reduce all of those data into a single FITS file. And that filler runs in real time while you're observing. So you can, hopefully, if we type GBT IDL, I'm not sure what's actually being observed right now, so that may affect what we're looking at. But if this was your project you're observing, if you just type online, normally you would see that this would be a few minutes at most. This is the online file. It just connects to the latest file to be read. And I'll just do a quick summary to see what was observed. And whoever was observing last, this is what they were observing, and gives you just some short information about it. There can be errors in this filling. So what happens is if you have a large data rate, sometimes the filler can't keep up and it will actually skip scans. Just to try and keep up with the real-time aspect of it. Now, that doesn't actually happen that often, but it can happen. So it's important for you to be aware of it and to go back and look at your summary and check that all your data are there, all your integrations are as expected, and so on. Otherwise, you might want to refill your data, and you can do that simply by typing. Well, I'll get into that in a second. Something else useful in GBT IDL is if you there's just a lot of information available to you on any particular scan. By typing list cols, which I just did, it gives you all of these columns that are available to you in your online FITS file. We also have something called the spectrum data container, which we refer to as bang.g.s *0. And this is meaningless to you like that. However, each of these columns has a label, and these are all spelled out in the GBT IDL user guide, which I've linked to in my slides. And so let's just pick one, reference frequency. Now that's going to come up as 0 because there are no data actually attached, even though we have access to the larger FITS file. I actually need to reference a scan to access the spectrum container. So let's just do a quick get PS for a very simple fast reduction of the position switch data here. Hopefully that should work. So there we go. We're looking at somebody else's data. I should just close that down because I probably shouldn't be looking at. But that does now give me access to their spectrum data container. So there's their reference frequency. So if you're just trying to double check that, in the examples I'm giving, I'm using GBT IDL essentially as a quick look data reduction tool. And so you just want to make sure that your data aren't doing anything crazy, your baselines look all right, and your reference frequency is what you think it is, or think it should be, then this is sort of how you would do that. I'm actually running pretty low on time. So a lot of what I'm saying is quite easily available in the links that I've posted. I've pretty much covered what I was going to say about SD FITS anyway. Just to be careful to make sure it has properly filled your data, or you may need to go back and redo that. And I have some short instructions there. One thing you will probably get if you ever do refill your data is you will get this warning, and there just doesn't seem to be any way to not get that warning, at least not in any way that we recommend. So you'll just have to accept that warning and move on. Don't worry about it. Yeah. And we have a GBT gridder tool, which helps to map all of your data. If you're taking mapping observations, GBT Gridder is probably the method you'll use to actually create your Sky map FITS files. And you'll definitely need to talk to your project friend about how you're going to use that. Take some practice. You need to make sure all your input data is calibrated before you put that in. But as I said, yeah, you should talk to your project friend about that. And there's lots of other software available on our systems. We have access to various astronomical software, different versions of Python, and so on. So that's for you to investigate, and your project friend will be able to assist you with that as well. Okay, so that's all I really had for now. It's a bit of a flying run through of the GBO system, but I'm happy to answer any questions, and you can always email me if there's any questions we don't have time for now.
Thank you, Larry. There are no questions in the chat. If someone does have a question, they could either type it in or unmute themselves. And like Larry said, this was meant to be sort of a 10,000-foot view of the Green Bank computing system for people who are not as familiar with the Linux systems. So I learned a few new tips to use too, so thank you.
Anytime.
All right, I don't see any questions in here. So